Good afternoon, everyone. Today we'll be discussing the implementation of a Beowulf cluster and its application in high-performance computing, specifically focusing on image processing algorithms. So, for the agenda, we have an explanation of what a Beowulf cluster is, its applications, some image processing algorithms, our developed system that implements a Beowulf cluster, and the final takeaways from our project. So, let's start with an introduction to the Beowulf cluster. A Beowulf cluster is a type of high-performance computing or HPC system composed of standard off-the-shelf computers known as nodes, connected through a high-speed network. Unlike traditional supercomputers, Beowulf clusters are more affordable and flexible. They are scalable, allowing us to add more nodes as needed, and can consist of homogeneous or heterogeneous nodes, making them versatile for various computational tasks. Also, the Beowulf cluster architecture includes computational nodes, which perform the actional data processing, and a head node, which coordinates tasks and distributes workloads. These nodes communicate through a high-speed network, typically Ethernet, and run a Linux operating system for stability and compatibility with HPC applications. Also, the management software such as Slurm or Torque is used to schedule and manage tasks, while message passing libraries like OpenMPI enable efficient communication between these nodes.
Beowulf clusters are used in various fields due to their computational power. Three primary applications include scientific simulations, image and video processing, and data modeling and analysis. Beowulf clusters are ideal for simulations in physics, climate modeling, and computational biology, where massive computational power is needed to process large datasets and perform complex calculations. These clusters are highly effective in processing large volumes of image and video data. Tasks such as real-time video processing, medical imaging, and remote sensing benefit significantly from the parallel processing capabilities of a Beowulf cluster. In the era of big data, Beowulf clusters are employed for data mining, machine learning, and large-scale data analysis. They enable faster data processing and allow researchers to gain insights from vast amounts of data in a shorter time.
Now, let's focus on two specific image processing algorithms that we implemented on our Beowulf cluster. First is the Gaussian filtering. This algorithm is used for image smoothing and noise reduction. It involves convolving the image with a Gaussian kernel. By dividing the image into smaller segments and processing them in parallel across multiple nodes, we significantly reduce the time required for filtering. Then the edge detection. The Soul algorithm is used to identify edges within an image by calculating the gradient magnitude at each pixel. Parallelizing this algorithm involves distributing different sections of the image into various nodes, where each node independently calculates the gradient, and then the results are combined to form the final edge detected image.
Now I'm going to tell you about our development system. In our project, we configured a Beowulf cluster with at least 4 nodes. The number of cores used by each node is variable because the nodes are personal computers, and these vary in terms of architecture and components. Each node uses a Ubuntu 20.04 operating system. It's because you must need the same image in each node. So then we use the OpenMPI for communication between each node, in this case using the 4.0.3 version. In another fact, you must need have the same files in each node. So in this case, we use the NFS network tool to create a shared folder and share all of the files in the main node for the other nodes. So we implement the Gaussian filter and slow edge detection algorithms by running these algorithms in parallel, and we observed an insignificant improvement in processing times. So here is, for example, in results of Gaussian filters, you can see how time increase with each decrease in the number of slots. The number of slots is the same number of tasks running at the same time. For example, in this case, from 18 slots to 2 slots, you can see how to the time increase. In another result, in this level algorithm, you can see the same. The time increase with decrease the number of workers. In our results demonstrate the effectiveness of parallel processing in handling large image datasets.
Okay, so now moving on with some of the key points that we as a team identified after finishing the implementation of this Beowulf cluster is that first of all we were able to demonstrate how the parallel execution of some image processing algorithms on a Beowulf cluster they greatly enhance their performance and reduces their processing time. In this case, we worked with image processing algorithms, but we are confident that other type of algorithms, if they are able to be parallelized, they could benefit from the implementation of the Beowulf cluster. Second of all, we were able to experiment how Beowulf clusters are scalable and can be easily expanded to meet increasing computational demands. Also, we were able to experiment how using off-the-shelf hardware makes Beowulf Cluster a cost-effective solution for high-performance computing needs. We didn't have to buy any extra hardware or any. We didn't have to invest in another computer. We used our own hardware, which is really nice. Really nice thing about Beowulf clusters. Also, we want to point out how the efficient communication between nodes using MPI it's really crucial for maximizing the performance of parallel algorithms. Really, without an effective communication between nodes, in this case we used OpenMPI, which is a great tool, but without a good communication, it's really impossible to achieve the parallel processing in distributed systems like this one. Also, we want to point out that Beowulf clusters are versatile and applicable to a wide range of fields, going from scientific research to data analysis or image processing, like in this case. Also, we want to point out how this project provided some valuable hands-on experience for us with HPC tools and techniques, preparing us for future challenges in other computational fields. And with that, we end our presentation of the Beowulf cluster implementation, and we wanna thank you for your attention.